we have this one that is the integration of dx over square root of 4 minus 9x squared. Okay? Now, we know that this type of equation is similar to, we have the integration of du over square root of a squared minus u squared, in which our a, again, this is constant. So therefore, our a squared here is equal to 4. Correct? Now, if we get a, that is just a square root of 4, then we have 2. Then our u here, our u squared, that is 9x squared. U squared is equal to 9x squared. So therefore, our u is just the square root of 9x squared, is 3x. So therefore, we can rewrite this as dx over square root of 2 squared minus, we have 3x squared, in which this one is our a and this one is our u. So we can use trigonometric substitution to this problem. We just need to plot a and u in our right triangle, our theta. So therefore, since we have a minus sign in between, our a here, this one, is the hypotenuse. The first term is the hypotenuse. So therefore, our hypotenuse here is 2, not 4. Okay, since we have a squared, so our a here is 2. So therefore, the hypotenuse is 2. Now, our 3x, this one, is the opposite. So we have 3x in this case. So we can now use sine to this one, that is sine of theta is equal to the opposite 3x over the hypotenuse 2. Correct? So therefore, we can say that this one is 3x is equal to 2 sine of theta. And therefore, this one as our u, okay? And this one is our a. So it resembles to my previous example, that is u is equal to a sine theta, if you remember my previous example. So therefore, we substitute this one into this form. Now we know we have dx here. So therefore, we get the derivative of this. That is just, actually we can express this one as x is equal to 2 sine of theta, so over 3, correct? We put 3 in the denominator, then we have our derivative of x here, that is 2/3, the derivative of sine, that is cosine of theta. D theta, we substitute 2/3 cosine theta, d theta in our dx. Okay, so we have here our dx, that is the integration of, since we have dx is 2/3 cosine theta d theta, then we have 2/3 cosine of theta d theta over the square root of, now we have 2 squared, that is our a, so we can just write it 4 na lang, minus, now we know that our 3x here, that is equal to 2 sine theta, correct? However, it is being raised to 2, so we can say that it is 2 sine theta then squared. So we evaluate, now 2/3 is constant, we can actually take out 2/3 outside of the integration, that is 2/3, the remaining in the numerator, that is cosine of theta d theta over, we have here square root of 4 minus 4 sine squared theta, correct? That is equal to 2/3 the integration of cosine theta d theta. Now inside the radical, we can factor out 4, that is we have 4 times 1 minus sine squared theta. Okay, so we just move 4 out of the parenthesis, 1 minus sine squared theta. So we have, by further evaluation, we have 2/3 the integration of cosine of theta d theta over, now take note, we can rewrite this one as 4. Then 1 minus sine squared theta is the same as with the trigonometric identity for 1 minus sine squared theta is equal to cosine squared theta. So therefore, this is cosine squared theta. So we change 1 minus sine squared theta into cosine squared theta so that we could say that it is 2/3 the integration of cosine theta d theta over, if we have square root of 4, that is 2, correct? And the square root of cosine squared theta, that is cosine theta, correct? Since we have a squared and 2, the square root of 4, that is 2, the square root of cosine squared theta, that is cosine theta, since it is raised to 2. So we can cancel out cosine theta here, okay? And the remaining would be in terms of, since we have 1/2, we can take 1/2 outside of the integration. We have 2/3 times 1/2. The remaining in the integration is we have d theta. So therefore, if we have 2/3 times 1/2, it gives us 2/6. And then inside the integration, we have d theta. So that gives us 2/6. This is 1/3. Then the integration of d theta, that is theta plus c. Now we know from this form here, we can say that our theta is just equal to arc sine of 3x over 2, correct? So our theta here, that is the inverse sine, then 3x over 2. So we have here 1/3 our theta, that is arc sine of 3x over 2 plus c. So we take our function x back to our integration, okay? So we change everything into x again. So therefore, our theta here, that is from this problem, that a sine theta is equal to 3x over 2. Then we have theta here, that is equal to arc sine of 3x over 2. We substitute arc sine in the value of theta, so we get this answer. This one is now the integration of dx over square root of 4 minus 9x squared. Okay? Now, what if we try to use the derived integration rule? That is, we have this rule here, that is du over square root of a squared minus u squared, that's equal to arc sine of u over a plus c. So we have derived this one. Okay, so we can directly use this one instead of following those very tedious procedure or tedious solution. So we have the integration rule, that is, if we have du over square root of a squared minus u squared, that is equal to arc sine of u over a plus c. Now in our problem, we have this one here, diba? We have already determined the a. So our a squared here is equal to 4. So therefore our a here is 2, correct? Then our u squared here, that is the 9x squared. So therefore our u here is 3x. So if we try to substitute this here, we could have, so if we try to rewrite this one, we have dx over the square root of our 4 here, that is 2 squared, minus our u, that is 3x raised to 2. In this case, again, this is our a, and this one is our u. We can substitute a and u in this function. However, we need first to derive or to satisfy this form in which our du should be the derivative of our u. Now, if this our u here is 3x, then our derivative of u is equal to 3 dx, correct? But since we only have dx in the numerator, so we multiply here 3, no, just to satisfy du, then 1 over 3 outside of the integration. So hence we have satisfied this form, that is, this one is du, and this one is a squared, and this one is u squared. And remember, we have 1/3 outside of the integration. So therefore, we can use this form, okay, after we have satisfied this form. So we can directly use this integration rule. So that is, we have 1/3 arc sine. Our u here, our u is from there, that's 3x, correct? That is 3x over a. Our a here, that is 2. So we have over 2 plus c. So imagine how very useful it is if we just familiarize this rule compared to the very tedious solution using trigonometric substitution. Okay, so I would suggest you just memorize, okay, or familiarize this integration rule. Now we have our example here, that is the integration of dx over x squared minus 4x plus 13. Okay, so upon looking at the value here, the equation below, we can't use any integration rule to this one, nor the present rule that I introduced, that is a square root of a squared minus u squared, and so on. Now in this case, we need to convert this into a square of binomial. Okay, so what are the example of square of binomial? As if we have x minus a squared, that would give us x squared minus 2ax plus a squared. Remember your algebra, correct? If you have x minus 3 squared, that would give us x squared, okay, minus 6x plus 9. Now how did I change this into this form? Now we have the rule for evaluating square of binomial, that is square the first term. So we have the first term here, that's x, so we squared, that's x squared. Then multiply the first term and second term and multiply the product by 2. Okay, so this gives us 3 times x, that is negative 3x, since we have negative, then times 2, that would give us negative 6x, correct? So it's x times negative 3 times 2, that is equal to negative 6x. Then lastly, you square the last term, that is, we have negative 3 squared, that is equal to 9. Okay, so we have plus 9. That's the rule from your algebra. So our goal here is to make this a square of binomial, this one. Now take note, we cannot directly convert it into square of binomial since we have 13. So what we're going to do here is to apply completing the square, in which in completing the square, we are going to introduce a number here so that we could apply square of binomial, or we can change that polynomial into square of binomial. Okay, so in this case, we have, let's say that's the integration of dx over x squared minus 4x. Now take note, so what should be the number that we should add in here so that we could create a square of binomial? Now we have x squared minus 4x, so if we try to add 4 to that, we can change this one into x minus 2 squared. How? I just divide 4 here by 2, the answer is 2, then squared, that is 4. Okay, the same as with x squared minus, let's say, 6x. So what should be the third term? So I divided 6 by 2, the answer is 3. Then I squared that one, the answer is 9. So therefore we add 9 here so that we could have x minus 3 squared as our square of binomial. So in this case, we have x minus 2 squared. Since if you evaluate this in this one, we could have square the first term, x squared, multiply the first term and second term, then multiply by 2, then we have negative 2 times x, that is negative 2x, then times 2, we have negative 4x, then square the last term, that is plus 4. So therefore, we add 4 here, correct? Now, don't forget, we still have 13. Now, upon introducing positive 4 in the denominator, the value of our equation has changed. Okay? In order to balance the equation, we need to add negative 4 in the denominator. Why? So that 4 minus 4 is equal to 0. We still have x squared minus 4x plus 13 in the denominator. Since if we have 4 here and negative 4 here, that will give us 0. So as if we are not changing our denominator. So as if now we are not introducing a number. Okay? So you need to come up with the same number but in opposite sign. So we have here the integration of dx over x squared minus 4x plus 4. If we have 13 minus 4 here, that would give us 9. Correct? And further evaluation, that is dx over, now take note, x squared minus 4x plus 4, the same as with x minus 2 squared. Correct? And our 9 here is the same as with 3 squared. Okay? So therefore, we can say that this is our u. Again, u is function of x. And this is our a, since our constant here is 3. Okay? So therefore, our u here is x minus 2. Our a here is 3. Okay? Or our u squared, that is x minus 2 squared. Our a squared is equal to 9. Or that is 3 squared. So therefore, we can use here trigonometric substitution. That is, we have to plot it into our right triangle. Now take note, since we have positive in between, that means neither of these two here is hypotenuse. So this one is opposite and this one is adjacent. So our function of x, that is the opposite, and our constant, that is the adjacent, that is theta. Again, if in this case we have the opposite and the adjacent, then we have tangent. That is, we have tangent of theta is equal to opposite over the adjacent. Correct? So we can now change all x here into a trigonometric substitution. But take note, we have dx here, so we need to come up with derivative of x. So by further evaluation, we have here 3 tangent of theta, that is equal to x minus 2, correct? Or that's x here is equal to 3 tangent of theta plus 2. So therefore, the derivative of x is equal to 3, that is secant squared theta, d theta. Correct? So we substitute 3 secant squared theta d theta in our dx here. Okay, so we have our dx, that is 3 secant squared theta d theta over, that is x minus 2 here, and we know that x minus 2, this one, is equal to 3 tangent theta, correct? And we have raised to 2, so therefore that is 3 tangent theta, that is squared. Again, since x minus 2 here, that is 3 tangent theta, that is 3 tangent theta, plus this one is 3 squared, 3 squared. So we further evaluate this one. We have the integration of 3 secant squared theta d theta over, we have 9 tangent squared theta plus 9, of course. And then take note, in the denominator we can factor out 9. So we have 9, that is tangent squared theta plus 1. Correct? So take note, 3 over 9, that is 1/3. 3 divided by 9 is 1/3, so we can take 1/3 out, that is 1/3 here. Okay, cancel 3, and this one, the remaining would be 3. So we have 1/3. And then we have secant squared theta d theta over. Now we have tangent squared theta, theta plus 1, that is equal to secant squared theta. And then again, we can cancel out secant squared theta. Then the remaining would be 1/3 the integration of d theta. So we have 1/3 theta plus c, and this gives us, now we know that our theta here, that is from this equation, we have theta is equal to arc tangent of x minus 2 over 3. Correct? So therefore, we can say that our theta here is 1/3 times arc tangent of x minus 2 over 3 plus c. So let's substitute back our function of x to our equation. This should not be our final answer, correct? So since our original function is in terms of x, so we should take x back in our equation. So our answer here is 1/3 arc tangent of x minus 2 over 3 plus c. And now this one is the answer for the integration of x squared minus 4x plus 13. But I know it is quite long, or it is very tedious procedure. So let's try to use the integration rule that we have introduced in the past video. So we have these 3 integration rules that I introduced, but the only rule here that we could apply to the problem is that this one, that's the integration of du over a squared plus u squared, since we know that it does not involve radical, and we have already identified a squared and u squared. So we can use this form that is equal to 1 over a arctangent of u over a plus c. So we have the du over the integration of du, that is a squared plus u squared, is equal to 1 over a arctangent of u over a plus c. Okay, so rewriting our function, the modified function, that is we have dx over the x minus 2 squared plus 3 squared, correct? In which this one is our u and this one is our a. So we have the same form with the integration rule, this one, that is our a squared plus u squared, or u squared plus a squared. Okay, so apparently we can use this integration rule. Now we know that our u here, that is x minus 2, and our a, that is equal to 3. But before we can use this rule, we need to identify first whether we have satisfied our du or not. Okay, now if this is our u, x minus 2, our du should be dx. Now looking at the numerator, we have dx here, so we do not need to introduce a multiplier since we have already satisfied du. So we can directly use this rule here. It's 1 over a arctangent of u over a plus c. Now in that case, we have 1 over our a here, that is 3, arctangent of u. Our u here is the function of x, that is x minus 2, this one. So we have x minus 2 over our a. Take note, our a here is 3. So we have 3. So therefore, we have come up with the same answer using the trigonometric substitution. So imagine how very helpful it is if you familiarize this rule. Okay, however, it is also very important that you know the conventional procedure. So you can use either of the two, but I would suggest you know how to use both procedure. So therefore, we have the integration of dx over x squared minus 4x plus 13 is equal to 1/3 arctangent of x minus 2 over 3 plus c. So this is now our final answer. So I have here a new example. We have the integration of dx, or 1 over square root of 9 minus x squared minus 6x. So first, we need to identify, or we need to determine first what type of integration techniques that we could apply to this type of function. Now we have the square root in the denominator, we have the radical sign, so we would think immediately that this one is. So I have here a new example, that is, we have the integration of 1 over square root of 9 minus x squared minus 6x dx. So upon looking at the function, we could say that the best integration technique that we could apply to this one is the trigonometric substitution. Okay? However, in trigonometric substitution, we need to get first, or we need to have a function that is in terms of u squared plus a squared, or just the a squared minus u squared, okay, or u squared minus a squared. Okay, so we have to create, or we have to change this denominator here into this type of function, okay, into its form. How are we going to do this one? So take note, since this is quadratic, we can convert that, or we can change that into a square of binomial by again completing the square. So we can rewrite this into the integration of, we can put dx in numerator over the square root of, we have 9. Now we have negative sign here in between, so we can factor negative out. We have negative times the remaining would be x squared plus 6x. Okay, so in this case we have x squared plus 6x, so we need to introduce a number that could make this into square of binomial. So we have x squared plus 6x. So if we divide 6 by 2, we could get 3, and the square root of 3 is equal to 9. So therefore we can say, or we could have here plus 9. Okay, so introduce plus 9 here, and since we have added 9, so we should introduce 9 outside of the parentheses, okay, but in opposite sign. Now since our negative here is in outside of the parentheses, so we have negative 9 here, correct? So therefore we should add positive 9. Okay, so we have plus 9. Why we need to introduce plus 9? Again, to balance the equation. Since we have negative times, if we try na simplify it further, we could have square root of 9 minus x squared minus 6x, then negative times 9, that is negative 9, then we have plus 9 outside, so this would become 0. So therefore our function has not changed, since we are as if adding 0 in the denominator. So we could say that it is dx over square root of, now we can add this one, we have 9 here, and this 9, the rightmost side, we have 9 plus 9, we have 18, then the remaining would be negative, then x squared plus 6x plus 9 here. Now we have the integration of dx over square root of, now take note, 18 here is our a squared, okay? Now this one is our u squared, correct? So if our a squared is equal to 18, then therefore our a here is square root of 18, correct? If our u squared is equal to x squared plus 6x plus 9, take note our u is function of x and our a is constant, then we know that this one here could be transformed into a square of binomial, correct? So we have u squared here is basically equal to, that is again, how are we going to change it into square of binomial? So since we have the last term here is 9, so therefore we have 3. So we have x plus 3 squared. Since again, if you want to evaluate this one, we could have square of the first term, x squared, multiply the first term and second term, we have 3x, okay, times 2, we have 6x, then square the last term, that is 9. That is the rule in evaluating square of binomial, or you can just simply use the what we call the funny face, diba? X plus 3 times x plus 3, that is just multiply the first term and first term, then first term with the second term, then the second term and the first term, and the second term and the second term. Okay? So we can say that x squared plus 6x plus 9 is equal to x plus 3 squared, in which our u here is equal to x plus 3. So therefore, we can say that in our radicand, we have our a dot, in that case, that is square root of 18 squared, okay, minus we have x plus 3 squared. Again, this one is our a squared, and this one is our u squared. Now, what type of rule is this one? We have the integration rule, that is the integration of du over the square root of a squared minus u squared is equal to, we have arc sine of u over a plus c. We have derived this one from our previous example, correct? So by substituting this one to this one, we have, however, we need to satisfy first our du. If our u here is x plus 3, then therefore our du is dx, correct? Since we already have dx here, since we have satisfied our numerator, that is only dx, again, if we are lacking of any number here, so we multiply or we introduce a multiplier, then the reciprocal of that multiplier outside of the integration. But in this case, since we only have dx, so we have dx here, that's our du, so we can directly use this formula here. Okay, so we have, that is arc sine of u, our u here, that is x plus 3, over our a here, our a is square root of 18, correct? So we have square root of 18 plus c. So therefore, this one, so this is now the integration of dx over square root of 9 minus x squared minus 6x. Okay? Now, how about if we try to solve it using the conventional way, that is the trigonometric substitution. So we have here, by trigonometric substitution, we have to plot this in our right triangle. Okay? Since in our radicand, we have this form, the square root of a squared minus u squared, this one, we are sure that our a here is the hypotenuse, since again, we have the different sign in between two terms. Okay, and the first term here, that's the hypotenuse, that is our a, and u here, that's the opposite of our angle theta. Okay, so our trigonometric identity that we could use in this one is we have sine. Okay, we have sine of theta is equal to opposite, that is u, over the hypotenuse, that is a. So therefore, we have u, that is equal to a sine of theta. Correct? Now, if we get the derivative of u, then we could have a cosine of theta. Okay, let's try to do this form here, in which this one is our a and this one is our u. So therefore, we have our u is equal to x plus 3, and our a, that is the square root of 18. So we need to substitute this one. Now, when we plot this in our right triangle, we have our a here, that is the hypotenuse, that is square root of 18. So this is this one here, that's square root of 18. The opposite here, that is our u, that is x plus 3. Again, u is the function of x plus 3. Okay? So we can use sine theta that is equal to opposite over the hypotenuse that is square root of 18 from sine theta is equal to opposite over the hypotenuse. So if you remember your trigonometry. Now, we substitute, okay? So we can say that x plus 3 here is equal to square root of 18 sine of theta. Okay? So we can change this x plus 3 here in terms of square root of 18 sine theta. Now, we have dx in the numerator, so we need to derive this one. So we have dx, the derivative of 3 is 0, and then the derivative of sine theta, that is equal to square root of 18 cosine of theta. So let's substitute this value to our original form, that is, we have dx, that is square root of 18 cosine of theta, then we have d theta, it's a derivative, over the square root of, then if we have, if we try not to simplify this one, that is the square root of 18 squared, then that would give us 18, correct? So if we have square root of 18 squared, we know that square root of 18, that is 18 raised to 1/2, correct? Time raised to squared. So if we multiply 1/2 and 2, that would give us 1, since we can cancel out 2, so 18 raised to the 1, and that gives us 18. X plus 3 here, that is equal to square root of 18 sine theta. Then we have square root of 18 sine theta. Then since u here is raised to 2, okay, so we add 2. Then the integration of square root of 18 cosine of theta d theta over, we have square root of 18 minus, so we squared individually, so we have square root of 18 squared, that would give us 18. Then the square root of sine theta, that would give us sine squared theta, correct? Then after this, we can factor out 18 in the denominator. We could have integration of dx over square root of 18 times, we have, if we take out 18 in this term, the remaining would be 1 minus, now if we take out 18 in this term, the remaining would be sine squared theta. So we have integration of square root of 18 cosine theta d theta over, that is square root of 18. Now we know that 1 minus sine squared theta is equal to cosine squared theta, correct? So let's change that into cosine squared theta. So we could have the integration of square root of 18 cosine theta d theta over, now we can separate the square root sign, square root of 18. Now we have the square root of cosine squared theta is basically equal to cosine of theta, correct? If we get the root of cosine squared theta, that would give us cosine theta, since it is raised to 2. Now we can cancel all terms, correct? We can cancel this one, cancel this one. The remaining would be d theta, and the integration of d theta is equal to theta plus c. Okay? Now, from this term here, this one, we know that our theta here is equal to the arc sine of x plus 3 over square root of 18, correct? So therefore, we take back our original function to our theta value, okay, or we get back variable x and substitute it in our theta, then we have the answer that is equal to our theta is arc sine of x plus 3 over square root of 18, that is arc sine of x plus 3 over square root of 18 plus c. So this is now the integration of dx over square root of 9 minus x squared minus 6x. Okay? As what you can see here, the answer using the conventional approach and the answer using the trigonometric rule are of course the same. Okay?